Determine the minimum sample size required when you want to be 95% confident that the sample mean is within 2 units of the population mean, mu, and the population standard deviation, sigma, will be 1.4. Assume the population is normally distributed. I went ahead and provided the formula we will be using to determine the minimum sample size, n, that is needed to estimate the population mean, mu. Since we are assuming the population is normally distributed, we can use the z-score that corresponds to C, which is the level of confidence. In our case, the level of confidence, C, is 95% or 0.95. I provided the table to show you those that your textbook will use, and we can see that the 95% confidence level corresponds to a z-score of 1.96. We have our z-score, and it equals 1.96. We were also given the population standard deviation, which is represented by the Greek letter sigma, and that is 1.4. And the sample mean is within 2 units of the population mean, and this is our margin of error, E, which is going to be equal to 2. So we can now plug our values into this formula. We have 1.96, and we're going to multiply that by our standard deviation of 1.4. We're going to divide that by our margin of error, which is 2. So our numerator will be 2.744. We multiply 1.96 to the 1.4. I'll divide that by 2. So let's go ahead and solve inside the parentheses first before we square this. And we get 1.372. Now we square it. So we get approximately 1.8823. When determining a minimum sample size, we round up to the nearest whole number. Therefore, the minimum sample size needed to estimate the population mean is 2.